over 3,000 miles beneath our feet. At the very center of our planet lies a mysterious and largely unseen world. A solid iron spheroid, nearly as large as the Moon, burns at temperatures rivaling the surface of the Sun. This is Earth's inner core, a place so extreme that it challenges our understanding of physics, geology, and even time itself. It spins independently of the planet around it, generating forces that ripple all the way to the surface, influencing the magnetic field, plate tectonics, and even life itself. For generations, scientists have been captivated by this hidden heart, devising ever more sophisticated ways to study it. And now, the latest research has revealed something astonishing. Our inner core has not only slowed its spin, it may even be moving backwards. What could this mean for life on the surface, and how did we even discover this incredible secret? I'm James Stewart, and you're watching Discovering the Unknown. Today, we're journeying to the center of the Earth, exploring the inner core, uncovering its mysteries, and asking the question, how worried should we be? Number 10. Layers of the Earth. Our journey downwards. To reach the inner core, we must first journey through Earth's outer layers, each with its own critical role in shaping the world above. At the surface, we walk upon the crust, a brittle shell fractured into tectonic plates. These plates drift, collide, and grind against each other, causing earthquakes, volcanic eruptions, and mountains. Below the crust lies the mantle. Though it seems solid, the mantle flows extremely slowly, just a few centimeters per year. This imperceptible motion drives plate tectonics, linking deep Earth dynamics to the disasters and wonders we experience at the surface. Beneath the mantle is the outer core, a sea of molten iron and nickel. Its swirling currents generate Earth's magnetic field, a shield protecting life from the sun's deadly radiation. Suspended in this molten sea is the inner core, a solid sphere of iron that forms the planet's true boiler room, powering processes that affect everything from the shifting of continents to the orientation of the magnetic poles. Number 9. Discovery of Earth's core. Emil Wichert's insight. Understanding what lies beneath the surface was far from easy. In 1896, Emil Wichert addressed a pressing question: if Earth's average density is 5.5 grams per cubic centimeter, why are surface rocks only about half that dense? Wichert proposed a bold idea: the missing mass must be made of a much denser material, hidden deep within the Earth. Inspired by iron meteorites, he suggested that the planet's interior contains a massive iron core, dense enough to explain the discrepancy. This wasn't purely theoretical. Wichert combined mathematics with observation to make his case. His insight laid the foundation for modern geophysics, bridging centuries of speculation with a concrete model of Earth's inner structure. Number 8. Seismology. Listening to the Earth. We cannot drill to the Earth's core. Even the deepest borehole, Russia's Kola Superdeep, reaches only 12 kilometers, less than 0.2% of the way down. Instead, we rely on seismology, the study of earthquakes. The invention of the modern seismograph allowed scientists to record tremors with precision, measuring waves that travel through the Earth. By analyzing these waves, geologists could infer the planet's internal composition. Richard Dixon Oldham in 1897 studied seismic waves from a massive earthquake in India and noticed 3 distinct wave types: primary P waves, secondary S waves, and surface waves. P waves travel through both solids and liquids, S waves only through solids. Observing where and how these waves propagated gave scientists the first real insight into Earth's hidden core. Number 7. Inga Lehmann, discovering the inner core. Despite decades of seismology, the Earth's core remained partially mysterious until 1929, when Inga Lehmann, a Danish seismologist, made a groundbreaking discovery. While analyzing P-wave data from earthquakes in New Zealand, she noticed waves appearing in areas where they should have been blocked by a liquid core. Lehmann concluded that the core must have 2 parts, a liquid outer core and a solid inner core. Her observations, initially dismissed by some due to her position in a male-dominated field, turned out to be absolutely correct. The solid inner core was the final piece of the puzzle, revealing a complex, layered structure deep within the Earth. Number 6. The inner core's rotation moving to its own beat. Once the inner core was confirmed, scientists asked a new question: does it rotate with the planet or independently? During the Cold War, advanced seismographs developed for Project Vela Uniform to detect nuclear tests allowed researchers to measure seismic waves with unprecedented precision. By examining waves traveling through the inner core along different axes, scientists discovered anisotropy. The crystalline iron inside the core is aligned slightly off-axis with the Earth's rotation, allowing waves to travel faster in one direction than another. This observation provided a method to measure the inner core's rotation, revealing that it spins at a different rate than the mantle and crust above. Number 5. Earthquake doublets, tracking core movement. To detect this rotation, researchers studied earthquake doublets, nearly identical quakes occurring decades apart. By comparing seismic waves from quakes in the South Sandwich Islands between 1967 and 1995, scientists at Columbia University observed that the waves traveled faster and faster through the inner core. This was the first observational evidence that the inner core rotates independently, confirming a phenomenon that had long been theorized but never measured directly. Number 3. The 70-year cycle slowing, stopping, and reversing. Recent studies have revealed that the inner core's rotation is not constant. In 2023, Peking University scientists found that the core's spin has almost paused and, relative to the mantle, has even begun rotating slightly backwards over the past decade. This behavior mirrors a similar occurrence in the early 1970s, suggesting a 70-year oscillation cycle. Seismic data from the University of Southern California confirmed this cycle, showing that the core alternates between speeding up and slowing down, almost like a cosmic clock ticking deep within our planet. Scientists speculate that magnetic interactions with the outer core and gravitational forces from dense mantle regions may drive this oscillation, though the exact mechanism remains a mystery. Number 2. Impacts on Earth, tiny yet significant. What does all this mean for us on the surface? Thankfully, the changes in the inner core are subtle. The 70-year cycle correlates with tiny fluctuations in the length of the day, shifts in Earth's magnetic field, and even minor changes in global temperature and sea level. These variations are minuscule, a thousandth of a second here, a fraction of a degree there, and are not linked to climate change. However, the inner core remains the planet's boiler room, and any changes in its behavior ultimately ripple outward, influencing processes that sustain life on Earth. Number 1. The ongoing mystery. Even after more than a century of research, the inner core continues to surprise us. With ever-improving seismic networks and decades of data yet to analyze, scientists are still discovering new aspects of its behavior. As Inga Lehmann once wrote, "Much has been written about it, but the last word has probably not yet been said." The inner core reminds us that despite all our technological advances, Earth still holds secrets that challenge our understanding of time, motion, and the forces that shape our world. So, what do you think? Is the inner core's mysterious rotation something to worry about, or just another incredible reminder of how little we know about our planet? Let us know your thoughts in the comments below. If you enjoyed this journey to the center of the Earth, make sure to subscribe to Discovering the Unknown for more deep dives into the mysteries of our world. Because when it comes to the deepest, darkest secrets of our planet, we're just scraping the surface.